Today, SpaceX continues testing the most powerful rocket in history. Starship's 8th test flight is just around the corner, and we're about to witness it. In this video, we'll break down the details of the upcoming mission, see how far this program has come, and find out what tests await Starship this time around. And before we get to the launch, let's remember the purpose of the Starship project. Starship is not just a rocket. It's a system that's set to change the rules of the game in space. SpaceX is developing it as a fully reusable transportation system capable of carrying people and cargo to orbit, the Moon, Mars, and beyond. The goal of the project is to create an affordable and sustainable way to explore the solar system. With in-orbit refueling and high payload capacity, Starship will be able to carry hundreds of tons of payload and dozens of passengers beyond Earth. For the first time in history, mankind will have the opportunity to build colonies on other planets. But before this becomes a reality, many tests must be carried out. And each of them is one more step towards making Starship a truly revolutionary rocket. Starship became a full-fledged rocket system. SpaceX conducted a series of test flights of second-stage prototypes. These tests helped refine key landing, aerodynamics, and propulsion technologies. SN8, December 9, 2020, first test flight with controlled aerodynamic braking. Starship SN8 reached an altitude of 12.5 kilometers, performed a controlled belly flop, a maneuver involving a transition to a horizontal attitude, and began a reverse transition to a vertical orientation for landing. However, due to insufficient propellant pressure when the engines were turned on, the rocket lost throttle speed and crashed on landing. SN9, February 2, 2021. The purpose of this test was to repeat the flight of SN8 with corrected errors. Starship successfully completed all maneuvers, but one of the engines failed to start on landing, resulting in a crash. SN10, March 3, 2021. The first prototype that managed to make a landing. However, due to too high a vertical speed, the landing gear legs were damaged on touchdown, resulting in a fuel tank rupture and explosion a few minutes after landing. SN11, March 30, 2021. The launch took place in heavy fog conditions. Starship SN11 climbed to 10 kilometers, but during the landing maneuver, an explosion due to a methane leak occurred, destroying the vehicle in midair. SN15, May 5, 2021 prototype with improved design, new engines, and thermal insulation system. SN15 successfully reached an altitude of 10 kilometers, performed a rollover maneuver, and made a soft landing without destruction for the first time. This test was an important step in the development of Starship's reusable technology. Each of these tests provided SpaceX with valuable data to improve the Starship's design and prepare it for full test flights. The first comprehensive tests of the entire system are ahead, and this is a completely new stage in the development of Starship. The first integrated flight of the entire Starship and Super Heavy system. The goal of the mission was to prove that the rocket could successfully break away from the launch table and pass the stage separation stage. However, at an altitude of 39 kilometers, the Starship was destroyed by the emergency flight termination system due to loss of control. Despite this, the test confirmed the operability of multiple systems and was the first step towards a full orbital mission. On the second test flight, SpaceX improved many systems. The rocket launched successfully, but 2 minutes after takeoff, the Super Heavy lost communication and exploded. The second stage continued the flight, but was also later destroyed by the safety system. Nevertheless, the test showed successful separation of the stages, an important advancement in Starship development. The primary goal was to demonstrate a controlled descent of the first stage and bring the second stage to orbit. Booster first performed a soft landing in the Gulf of Mexico, and Starship successfully re-entered space. However, during re-entry, the craft collapsed due to overheating. This test gave SpaceX invaluable data on the ship's thermal protection, the flight in which the in-orbit refueling system was tested for the first time. Although no docking with another ship was performed, Starship demonstrated the ability to maneuver in space. The first stage was lost while attempting a soft landing, but the second stage lasted longer than in the previous test. SpaceX has new data on the ship's behavior in orbital flight conditions. Key target is the first attempt to capture the first stage using Mechazilla. Booster successfully returned to the launch pad and was caught by the manipulators. Starship reached orbital trajectory and then landed in the Indian Ocean, where it was lost after landing. This test confirmed the operability of the first stage return system and brought Starship closer to full reusability. The sixth integrated test flight took place on November 19, 2024, and was aimed at practicing the reusability of the system. For the first time, Starship achieved positive perigee and also successfully refired the Raptor engine in space. The first stage of the Super Heavy made a controlled landing in the Gulf of Mexico, but was lost. The second stage re-entered the atmosphere and successfully landed in the Indian Ocean during daylight for the first time. This flight confirmed the performance of hot separation, reignition in space, and controlled spacecraft re-entry. Perhaps the most ambitious test, Booster made a successful return to the launch pad, confirming the reliability of the Mechazilla system. The second stage performed normally, but communications were lost 8.5 minutes after liftoff, and the craft broke up in the atmosphere. However, this was the first flight of an updated version of the ship, Starship Block 2, which should be the basis for future missions to the Moon and Mars. Improved design and new heat shield tiles were key elements of this flight, and the data collected will help prepare the next attempt. Now SpaceX is moving on to IFT-8, and this launch could be a pivotal one in the project's history. But before that, let's break down exactly what's in store for today's mission. Today, SpaceX is once again testing the boundaries of what is possible. With the IFT-8 mission, the company continues to develop the most powerful and fully reusable rocket system in history. This launch will be the next step toward achieving the main goal, to create a system capable of transporting cargo and people to the Moon, Mars, and even beyond. The main objectives of the flight: testing the landing of the first stage of Super Heavy on the launch pad, testing the strength of the Starship structure during re-entry, and analyzing the effectiveness of the control system during the ship's return. The first stage, Super Heavy Booster 15, is powered by 33 Raptor 2 engines and carries the main load at liftoff. During the mission, it will perform a controlled descent and attempt to land directly on the launch pad using the Mechazilla capture system. This massive tower with two giant arms was specifically designed to grab and hold the rocket during landing. If SpaceX is able to pull off this maneuver, it will be a revolutionary breakthrough in aerospace engineering, reducing the time between launches and lowering flight costs. The second stage, Ship 34, will climb to suborbital altitude and then begin a controlled descent into the atmosphere. At the same time, the outer shell of the ship will experience extreme stresses. The speed of entry will exceed 25,000 kilometers per hour, and the temperature on the surface will reach several thousand degrees. To capture this moment, SpaceX will use an airplane Gulfstream V. It will be at an optimal point in the sky and will record the process of destruction of the heating layer of the ship, evaluate the behavior of the structure, and allow engineers to obtain unique data for further improvements. IFT-8 is not just another test. It is a critical step in Starship's development. If the Super Heavy landing is successful and the data on the second stage's re-entry behavior yields valuable results, SpaceX will be one step closer to a fully reusable system. If successful, this will mean one thing: Starship is getting closer to its primary mission, to become the next generation vehicle that will open the way to the stars for humanity. This launch is another step toward creating a system that can take people and cargo to the Moon, Mars, and beyond. SpaceX is once again defying the laws of physics, once again testing the limits of the possible, once again going where no one has ever been before. There have been many tests along the way, from the first high-altitude tests of the second stage to the most complex integrated flights. Each test brought not only failures, but also important discoveries. With each mission, the system became better. The engines worked more accurately, aerodynamics and thermal protection were improved, and new landing technologies were introduced. IFT-8 will summarize all previous tests and show how far SpaceX has come in developing a fully reusable rocket. If the mission is successful, it will be a critical step toward a transportation system that could revolutionize spaceflight. Today, we are watching history. Every test, every launch, every new line of data is part of a huge journey that will lead us to a future we could once only dream of. Follow the mission with us. Subscribe so you don't miss this great event. January 16th, 2025. The day when millions of enthusiastic spectators from all corners of the Earth watched the flight of the new Starship rocket. This flight was to be a new starting point on the way to the cherished goal of human missions to Mars, but Starship was engulfed by fire. Is this the end? No, it's just beginning. SpaceX is not backing down. Every launch is a step forward. Every explosion is new information. Each test flight is a foundation for a future where humanity leaves Earth not for a dream, but for reality. Today is a new stage. Today is another attempt. Today, we look to the sky again. This is Starship Flight 8.